Hello, grade 10s. So, today we are starting on a completely brand new topic. Okay, it's going to be in book 1. So, if you do your cover page, you can do your cover page being number patterns. Okay, number patterns is chapter 3 in your textbook. It starts on page 64. So, our heading for today is going to be linear number patterns. Okay, so the heading is linear number patterns. It's the first thing that we're going to discuss under number patterns, and you can write the date today, which is going to be the 8th of May. Okay, so just one small little note before we start with our example is that another word for the number patterns is also called linear sequences. Okay, just as a little side note, you'll see that a lot of textbooks do this differently, and some of the videos and other things that you might come across um, do it slightly differently. So I'll try my best to cover all the bases so that you are able to understand the topic fully. Okay, so let's start with an example. So consider the number pattern 5, 7, 9, 11, 13. And it continues. So I want you to pause and take a moment and try and figure out what will the next values be in the sequence. So just take a moment and try and figure that out for yourself. So look at the values that we have and then think, okay, what would come after 13? And then what would come after that? And so on. Okay, so I'm sure that you would have found that the next terms would have been 15 and 17 and so on. Okay, so if I ask you how did you determine that, you can almost see that, well, at every single point I'm just adding 2. So that is why it is referred to as a pattern, is because we identify that there is this general rule or pattern that occurs as we go from the one term to the other term. Okay, so let's take the same number pattern and let's look at some terminology. Okay, so I'm going to take the exact same sequence that we just used, which was 5, 7, 9, 11, 13. Okay, and I'm going to make some notes on this. So first of all, we call these numbers in the sequence terms. And terms are separated by semicolons. So we refer to 5 as term 1, term 2 would be 7, and so we continue. Term 3, term 4, term 5, and so on. Okay, so these are the terms that we talk about. Okay, so what we notice is that when we look at 5 and 7, the difference between them is 2. The same for 9 and 7, 11 and 9, 13 and 11. So we notice that what they have in common is this 2. So that's literally what we call it, because it's a difference and it is in common. We say that the common difference is 2. Okay, something that's important to take note of here is that all linear patterns in grade 10 have a common difference. Okay, that's what makes them this linear pattern, is the fact that they have a common difference. Okay, it's actually referred to as an arithmetic linear pattern, but we don't really worry about that too much this year. Okay, so let's consider we're looking at the same number pattern. If you wanted to calculate the common difference, so we'll call the common difference D. We would say, okay, well, we know for a fact that the common difference stays the same. And the way that we can find this common difference is by saying, well, if I take 7 and I subtract it by 5, I'll get 2. So I say that. I say, well, if I take term 2 and subtract it by term 1, I should get the common difference. And in this case, it would be 7 minus 5, which is equal to 2. But notice that the same is true if you take 9 minus 7. You also get 2, which is term 3 and term 2. So we can also state, well, if I take term 3 minus term 2, you'll also get D. So 9 minus 7 must also be equal to 2. Okay, and if we continue, we'll notice that the same is true for the fourth one. Term 4 minus term 3 is going to be 11 minus 9, which will just be 2 again. So notice that if we subtract one term by the term that comes before that term, then we get this common difference or constant difference. Okay. So what we need to do is we need to figure out how do we determine a general rule for such a number pattern. So let me repeat the number pattern again. It's 5, 7, 9, 11, 13. So notice now that we said that, well, the first term is equal to 5. Now, how would I get to 5? Because if I said, well, if I know the common difference is 2, then let me say, okay, well, I know that 2 multiplied by 1 is going to be 3. But now that's not equal, 3, sorry, is equal to 2. Goodness. So if you see that 2 and 5 are not the same, so we say to ourselves, okay, well, the only way to get from 2 to 5 is to add 3. So if I said, well, 2 times 1 plus 3, then I notice that I get 5. Okay, so let's have a look at the second term and try to use the same idea. That if I say, well, 2 multiplied by 2 now, 2 times 2 is equal to 4. But now to get from 4 to 7, I would add 3. So I can see that the pattern is repeating itself. So I would say, well, I could almost use this rule and write it in words and say, well, if I took the constant difference and multiplied that by the term number, So the term number are the little numbers at the bottom, and I plus 3, I would get the value, the actual number. Okay, so this rule is just for this particular number pattern above. So we could use this rule to find any term in the sequence. So if you wanted to know, okay, well, it's easy to find the next few terms by just saying 13 plus 2 will be 15 plus 2 is 17. But now what if I say to you, well, what is term 100? What's the 100th term going to be? Now that's a bit trickier, and you can't sit in a test and count in twos until you get to 100 terms. Okay, that's not going to work. So what you're going to do is you're going to say, well, the constant difference I just said is 2. And if I multiply that by the term number, which is 100, and add it to 3, then I see, oh, well, 2 times 100 is 200, plus 3 is just 203. Much quicker. So now what we do is we need to establish a rule that we can write mathematically. Okay, we can't just write out these words, because remember in maths we use variables and we try and write equations. So we find what is called a general rule, and we say, well, notice that if you take the term number and you put it into the rule, you'll get the actual whole value for T100. So if I look at this, I see, okay, well, T100 is equal to 2 times 100 plus 3. Because 203 is equal to T100. But now, if I wanted to replace this, I don't use x in this case just because it's something that is not often found. Instead, I'm going to replace it with Tn for number, because it's the term number. So I'm going to say, well, Tn will equal to 2 times n plus 3. Okay, so I can use this where I understand that this is now the general rule that I can use in order to solve for any term number in this entire number pattern that I've just worked out here. Okay, so if I continue, I'll see, just want to fix this. I'll see, well, the general rule for any linear pattern is what I call the general term. So the general term for a linear pattern says that Tn is equal to Dn plus C. Okay, where Tn is what I call the nth term. So I don't know, it's a general term, so it could be any term, the 5th term, the 7th term, but that, or the nth term, okay, just in general. Okay, the D I've already established is the common difference. And then the C value, we use C because the C value represents a constant number, which would essentially get us to the number that we want. Okay, so this is just a general equation that we use, and you'll see that it will probably make a bit more sense when we cover some more examples using it. Okay, so let's consider any general equation. So according to this, Tn is equal to Dn plus C, let's write that. So consider the equation Tn, which is equal to Dn plus C. Now, what would happen if I wanted to know what is T1? So take a moment and just write out a general equation that you would get if you had to put 1 in the place of n. So you can see that Tn, T1 is the same as D multiplied by 1 plus C, which is just D plus C. What about if I try to do it with T2? The same thing. D multiplied by 2 plus C, which is just 2D plus C. Let's do the next one. T3 and T4. So take a moment, pause the video, and write out the general equation for T3 and T4. Okay, so notice that the pattern just keeps repeating itself, but now replace n with 3 to get 3D plus C, and I replace this one with 4 to get 4D plus C. So if I put these terms into a general number pattern, and I said, well, T1, T2, T3, and T4 is the same as D plus C, 2D plus C, 3D plus C, and 4D plus C. Notice that every time all you're doing is you're just adding a D, which again is how we find that common difference. So we pick up on quite a few things here in this general equation that we've just found. And the first thing is that notice that T1 will always be D plus C. So that's something that's actually quite helpful to remember when we need to use it, that T1 is always going to be D plus C. But now what if I wanted to know what C was? Well, I could just take D to the other side and say, well, therefore I also know that C is equal to T1 minus D. Okay, so this is just some helpful things that we can use in order to just figure out how to solve for different number patterns. Okay, but let's tackle an example together. Okay, so it's going to be example, I think it's example 2. Yeah, example 2. But there are going to be certain questions that I'm going to ask you to do, to pause and do it yourself. So we have 6, 10, 14, 18, and so on. So the first thing I want you to do is I want you to write down the next two terms. So pause and figure out what the next two terms will be, and then from there we'll continue. So if you did it correctly, you'll notice that the next two terms after 18 would be 22, and then the next one would be 26. Okay, so the next question that I want you to do is show that the pattern is linear. So pause and try and figure out what we've previously done in order to prove that this number pattern could be a linear number pattern. So look at the notes take a moment and then we'll answer it. So I'm sure you'll notice that, well, we said that all linear patterns have a common difference. So if we see that it has a common difference of 4, because if I take t2 minus t1, you're going to get 4. And if you take term 3 minus term 2, you also get 4. So there is going to be a common difference. Okay, the next one, determine the nth term. So I start off with my general equation, which is Tn is equal to Dn plus C. I just established that the common difference is 4. So I'm going to put that in the place of D. And I'm going to say, well, Tn is equal to 4 times n plus C. Now, there are some ways to do this, but because we already know, we can use this general rule that we just found here, which is C is equal to T1 minus D. So if C is equal to T1 minus D, my number pattern starts with 6. So 6 minus the common difference, which is 4, is just going to be 2. So then Tn is equal to 4n plus 2, because the 4 comes from the difference and the 2 comes from the constant. So let's look at the next question. I say, well, determine now the 120th term. So what is this asking of me? Is it saying, is the term 120, or is it asking for the 120th term? In the sense that, is 120 in the number pattern? So are they asking for where 120 is in this pattern? No, they aren't, because they want to know what the 120th term is. So basically they want to know what is T120. So I'm going to look at my equation and say, well, Tn is equal to 4n plus 2. Now if T of 120 would be equal to 4 times 120 plus 2. So where you see the n, you replace it with 120. Okay, you'll put the whole thing in your calculator and you'll get 482. So that means that the 120th term in the pattern will be 482. Okay, then the last question in this example will be E, which says, which term of the number pattern is equal to 242? So this is going to be different than D. Notice that D, did they tell you what term you needed to find? Yes, they did. They said they wanted the 120th term. But if I look at this question, it says, do I know which term they want to find? No, because they have specifically asked me which term. So they said, now I have to find n. I don't know what n is. But I do know that 242 is the Tn, because they want to know where in the number pattern 242 is going to be. So I'm going to say, well, Tn is equal to 4n plus 2. But now they told me that 242 is Tn. So 242 is equal to 4n plus 2. Now all you do is you just solve for n like we always have, just like solving for x. So the first thing I'm going to do is I'm going to minus 2 on both sides. So you'll have 240 is equal to 4n. And then to get n on its own, you're going to divide by 4. So you'll do in your calculator and you'll get 60. So that means that t of 60 must equal to 242. Something to take note of is that n must always be a whole number. Okay, we don't ever talk about term number 2, 3. Like, that doesn't make sense. It's term 1, term 2, term 3, term 4. Okay, there's no terms that are in between those terms. Okay, so let's consider a general example. So I'll give you a try, and then you can pause, you can do the try, and then I'll give you the answer. So your try is going to be 3, 8, 13, 18. So pause the video. Oh, well, let me first give you your questions and then you can pause the video. So I want two things from you. I want the nth term, and then I want to know what is the 100th term. Okay, so pause the video and then attempt both questions, and then you can unpause and I will give you the answers. Okay, so first thing is that you can see that there is going to be a common difference. If you take term 3 minus term 2 should be equal to term 2 minus term 1. Let's see if that's true. So 13 minus 8 should be equal to 8 minus 3. And you can see both is going to be 5. So you found your common difference. So if I say Tn is equal to 5n plus c, then I can find c by saying, well, c is equal to t1 minus d. The first term is 3. The difference is 5. So you get minus 2. So Tn is equal to 5n minus 2. Now they said they want the 100th term. So T100 is equal to 5 times 100 minus 2. Therefore, T100 is going to be equal to 498. Okay, so let's look at another example. So you're told consider the linear sequence, and they give you 5x plus 2, 3x, and 2x plus 1. Okay, so don't get overwhelmed. This is your first term, this is your second term, and this is your third term. Okay, the questions ask you to determine the value of x. The second question says to calculate the 20th term, and then the question asks you to state which term of the sequence will be the first positive term. Okay, so there's quite a lot to unpack here. So let's start where it says determine the value of x. So I know that this sequence is a linear sequence, which means that I know that there must be a common difference. Okay, that's something that we know because they told us it's a linear sequence. So remember, the common difference, like I did previously, is this. So I can state, well, that must mean that if I took the third term minus the second term, I would get the same value as the second term minus the first term because of that common difference. So now let's do it. Now don't forget, we are replacing values, so you must put your brackets. Okay, the sign mistakes here are very bad, so make sure that you don't forget to do this properly. So the third term is 2x plus 1. The second term is 3x. The second term is still 3x, and the first term is 5x plus 2. Now you get rid of your brackets. So you'll say 2x plus 1 minus 3x, which is equal to 3x minus 5x minus 2. Okay, remember this negative is going to change the signs inside those brackets. Okay, then all you do is solve for x like normal. So you would have 2x minus 3x minus 3x plus 5x, which is equal to minus 2 minus 1. So all I've done is I've taken these two over, and I've taken the plus 1 to that side. So I have 2 minus 3, which is minus 1, minus 3, which is minus 4, plus 5x, which is just x. Minus 2 minus 1 is minus 3. Okay, then it says we must determine the 20th term. So they want T20. Now, you can't solve for T20 if you don't know what Tn is. So let's start with that. So Tn is dn plus c. Now, we don't know what the difference is. Okay, remember the x is just in the term. So let's take the x and substitute it in now. So remember the terms were 5x plus 2, 3x, and 2x plus 1. So let's put in the negative 3. So we have 5 times negative 3 plus 2, 3 times negative 3, and 2 times negative 3 plus 1. So 5 times negative 3 is negative 15, plus 2, which is going to be negative 13. Okay, this one is going to be negative 9, and 2 times negative 3 plus 1 is going to be negative 5. So now I have the first three terms. So I can find the common difference by saying, well, the difference is going to be t2 minus t1, which is minus 9 minus negative 13, which is going to be positive 4. So Tn is equal to positive 4n plus c. Now in order to find c, I can say, well, c is equal to t1 minus d. So I already know the first term is minus 13, the difference is 4, negative 4. So that means that minus 13 minus 4 is minus 17. So you'll say, well then Tn is equal to 4n minus 17. So now it's quite easy to find T20, because all we do is we just substitute in 20 in the place of n. So 4 times 20 is going to be 80, minus 17 is going to be 63. Okay, so that's the final answer there. Now, the last question is a bit difficult. It says, which term of the sequence will be the first positive term? So now we ask ourselves, okay, the first positive term, so Tn represents all the terms, right? So if I know that Tn is every term, or it's any possible term, they are basically saying, well, where is the first positive Tn value? So we want to know, where is T1 going to be greater than 0, because we want a positive number or positive term. So now you have to remember your rules of inequalities. So I know that Tn is 4n minus 3 is greater than 0. Now you just solve like normal inequalities, which is what we did last term. So we take the 3 to the other side, it becomes positive 3. And then we divide both sides by 4, so we have 3 over 4. Now remember, we can't have... Sorry, I don't know where I got these values from. So the pattern is 4n minus 17. Sorry, I don't know where I got 3 from. So it will be 4n is positive 17. So then n is going to be greater than 17 over 4. So if you don't know where this lies, what you have to do is you have to convert it into a mixed number, or you can write the decimal, it's up to you. So either a mixed number or decimal, because you need to figure out which whole number is bigger than this. This is what you're trying to find, the whole number bigger than 17 over 4. You don't choose any random number because it says the first one, which means you need to find the closest whole number that is bigger than this. So if you convert 17 over 4 into a mixed number, you will get 4 and a quarter. But if you decided to convert it into a decimal, you will get 4,25. Now, if they want the nearest number that is bigger than this, the nearest whole number that is bigger than 4 1/4 is going to be 5. And in this case, you can see the same thing. So we're rounding up because it's asking us for the whole number that is bigger than this or bigger than that. And you can't say 4 because 4 is smaller than this. So the next whole number that is bigger than this one must be 5. The same goes for this one. Okay, so this one is a little bit tricky, but you can also see that it's the fifth term. So if you actually just kept adding to this, minus 13, minus 9, minus 5, you could just keep going until you get to the first positive number, which would be 3, which is the fifth term. But please note that you have to do it using this method. You can't just keep going until you find the first positive term, okay? Because that's not always going to work. And so that's going to be a problem. So make sure that you know how to solve it using this method or a method of solving, and not just doing it for the sake of doing it. Okay, so for your homework, it's going to be exercise 3.1 on page 66 in your textbook. You're going to do the whole of A, except, well, let me not give you the whole of A. Let me give you numbers. So I'll give you number 4, number 7, nine, 12, and 13. 15 and 18. Okay, then I also would like you to do number B and number C. And also G and H. Okay, so it's quite a bit, but you have to practice this in order for it to make sense. Okay, remember, number patterns is by far one of the easiest topics that we do this year. So it's definitely the part, the section where you must get the highest marks possible. Okay, because it is going to be in your cycle and in your exam, and so it's a very nice section that you can score lots of good marks, and then you don't really have to worry so much about exponents and things like that, because now you have something that you can also fall back on. Okay, so make sure you go through all the exercises, make sure you rewatch the video if you need to get any further details, and remember, I am available if you need to ask anything. And yeah, good luck, and I'll see you on the next one.